You've probably heard of Perlin noise before. You know it's used in games for procedural generation. It is used to create realistic-looking terrain in games such as Minecraft, for example. Therefore, to someone inexperienced, it can seem daunting to try and use it for oneself. However, using Perlin noise isn't as hard as one would think. To understand how to use Perlin noise, at least in my experience, is to understand two things. One, it is an algorithm that outputs values from -1 to 1. And two, these values aren't random. They smooth into each other. Understanding these two things can really help with implementing Perlin noise into your projects. Since every noise library and game engine implements Perlin noise differently, I won't be going into how to specifically use it in code. Rather, I will be going over the two aforementioned things that will make it much easier to implement no matter what noise library or game engine you are using. Perlin noise outputs values from -1 to 1 after you input a position. So if I inputted the position 2, 6, for example, I would get a value like 0.1. It is also important to note that these values smooth into each other. So if I inputted 2, 7, I wouldn't get a value super far away from 0.1. I would get a value like 0.15. If we make -1 black and 1 white, we can get an image like this. This can be used to create height maps for games where black could be sea level and white could represent the highest point of a mountain. Sometimes it is really only useful to get a range from 0 to 1. To do this, you would just need to take the range -1 to 1, add 1, and divide by 2. -1 to 1 plus 1 gets us a range of 0 to 2, and dividing by 2 gets us to 0 to 1. If you want more numbers to play with, you can multiply the range of -1 to 1 or 0 to 1 by the range you want. For example, if I wanted my range to be 0 to 10, I would multiply 0 to 1 by 10. Perlin noise can really be used for anything that needs controlled randomness. You just need to map whatever you need randomized to the values outputted by the Perlin noise algorithm.